Welcome to this lecture. Let us see about the data structure stack. It is a linear data structure where element is inserted or deleted at one end known as a top. We will follow the LIFO order, that is last in first out or first in last out, to insert and delete an element. Whenever we are having an element, it will be added to the topmost position. This is a finite data structure. Whichever element is added first will be the last to be deleted from the stack. We have two different ways to represent stack in memory. The simplest one is arrays, which is a static implementation, and the next one is linked list, which uses dynamic implementation. Here we have a one-dimensional array. An array is a linear data structure again, which is a finite structure. We'll have the lower boundary and the upper boundary. The elements will be added to the topmost position and the stack pointer will be used to monitor the top always. We can have the size of the array to be determined by using the upper bound plus lower bound minus 1 to determine the size. So stack, this can be maintained by using a linked list where we have a head node and element will be pointed from the first one. This head node will have a pointer towards the first element and the first in turn will follow the second one, second, third and etc. up to n element, and the last element will be having no link, which will be represented by the null pointer. We have push operation. The process of adding an element or item to the stack is called as a push operation. The new element is added to the top position of the element. Algorithm. So here we have this push followed by this stack. The parameters are stack, top, n and item. This comment line is indicated by using double slash. Stack is an array with n elements. Top is a pointer to the top of the element of the array where the item is to be inserted. So the steps we have if we have to check whether the overflow has occurred, because we have a finite array. So top, if it has reached the maximum, then we have to print stack is full or overflow, and the process will be ended by this step. If not, top is incremented and element is added to the top of the stack, and this is a recursive procedure which is in turn an application of stack. And if we want to delete an element or item from the stack, this is known as pop, and it is made from the top of the stack. And here the algorithm pop has got stack, top and item as its input parameters. Since we are going to delete, we are not concerned about the maximum value that will be reached. We are concerned only with the underflow, while we want to check with the top if it is less than or equal to 0. If so, we want to print the status as print stack is empty or underflow, and if not, we can remove the element that is present at the top of the stack and store in this variable item. And top has to be naturally decremented, and this is also a recursive procedure. We have very different applications of stack. The most used are reversing a string. We may be using to check whether the given string is palindrome or not. And in many text editor, we will be using undo operation, and this is used, it is accomplished by using stack. In quicksort algorithm, for example, backtracking procedure is used. Backtracking, it means we want to come back if the solution is not able to be reached. Balanced parenthesis. So when you are having some expression to be solved, left parenthesis should be matched with the corresponding pair of right parenthesis. For that also we want to make use of stack. Recursion and towers of Hanoi and the evaluation of expression. Browser, when we want to navigate to and fro, when we want to come back, we can use this browser. This stack will be used. And the time complexity to perform the push, pop, is empty and peak all has got the uniform of big O of n time, as we do not run any loop in any of this operation. Every time we will be having either one element to be inserted or one element to be deleted, and we will be checking the status as whether it has element in it, whether it is empty or it has reached the maximum. And thank you for your patience listening of this lecture.